This video will go over how to factor trinomials in which the leading coefficient is not 1 and it's quadratic in form. So let's take a look at this first example. The first thing, no matter what, when you're factoring, is you always want to see if there is a GCF. So if we look 5, 21, and 4, we have to ask ourselves, is there a number that divides into all three of those terms? So in this one, there is not. And then we look, and they all do not have an x in their term. So we are going to skip step 1. There is no GCF in this problem. So the next step is we're going to start our parentheses like this. And now let me also say that this method that I am going to show you in this video is very different. A lot of instructors don't show that this way. Maybe they don't know that there is this method. So if you know how to factor these using trial and error or another method, I'm not saying that you can't use it, but this is the method that I've seen that students enjoy the most. So what we're going to do is we're going to take this. Our leading coefficient is 5, so we're going to take 5x and we're going to write that in the beginning of our parentheses. Then what we're going to do, so that was step 1, or step 2 here. Then step 3 is we are going to think of two numbers that multiply to a times c. So we know that this is a, the 5 is a, the b is 21, and the c is 4. So we need to multiply a and c together. So 5 and 4. And we multiply 5 and 4, we get 20. So we need to think of factors of 20. And then we need to pick the ones that not only multiply to a times c, but they have to add to get b. So they need to combine together to get this b term, which is 21. So if I pick positive 1 and positive 20, they multiply to 20 and they add to equal 21. So those are the numbers we're going to pick, and we're going to insert them. That is our next step. We're going to insert them into our parentheses here. So it doesn't matter where the positive 1 goes. We could put it here or we could put it here, but I'm going to put the positive 1 first and the 20 second. Then the next thing that we're going to do is we're going to take the numbers that are paired together and simplify them as if pretending like they were fractions. And we're going to throw out this factor since it doesn't go into the whole entire original problem from the start. So in other words, we're going to ask ourselves, is there anything that divides into 5 and 1? No, so we're going to keep it as 5x plus 1. And then over here we're going to ask ourselves, is there anything that divides into 5 and 20? And in this case it's 5. But we're going to throw that out. We're not going to write it in front of the fraction or in front of the parenthesis. And 5 divided by 5 is 1x. And 20 divided by 5 is 4. And that is our factored form. So let's check and see if this works. So the 5x plus 1 times the x plus 4. So if we multiply this out and we get our original polynomial, that's how we know that this method works. Then we have a 5x times 4 here, which is 20x. And then we have 1 times x, which is just x. And then we have 1 times 4, which is 4. And then we're going to combine the like terms. And as you can see, we get what we originally started with here. They're the same. So let's try this method out again. Let's try another problem here. So first thing is we always have to check if there's a GCF. If we don't do that, this is not going to work out. This method will not get us the correct answer. So is there a number that goes into 45, 60, and 20? So hopefully you're thinking 5 does. So since 5 goes into all three of them, I'm going to put that in front of the parenthesis, and then also they have y's in common in all their terms. And the one with the lowest exponent is just this one here. So we're just going to take that one and put it in front of the parentheses. So 5y goes in front. And then we're going to divide all the terms by 5y. So in other words, 5y times 9y squared would get us this. And 5y times negative 12y would get us this part. And 5y times positive 4 would get us this. And then just make sure that there is no number that goes into any of these and that you did indeed pick the highest number, which was 5. So now the next thing is this 5y is going to go in our final answer. It's not going to go anywhere, but let's ignore it now and let's follow our steps from above here. So we need to start our parentheses with our ax term. So we're going to put 2 parentheses here, and we're going to put 9y and 9y. And then the next part is we're going to multiply a and c. So we're going to take our a and our c. So this is our a, this is our b, and this is our c. So we're going to take our a, which is 9, and our c, which is 4, and multiply them, and write down the factors of 36. So now that we have our factors of 36, we have to choose the ones that multiply to 36, but they have to add to this b value here. So they have to add to negative 12. So since they have to add to a negative, I know that the larger number needs to be negative. So, and they have to multiply to a negative, so I know they have to have the same signs. So if I had negative 6 times negative 6, it would be positive 36, and negative 6 plus negative 6 is negative 12. So those are the numbers we're going to pick and put them in our parenthesis. And then we're going to see if there is anything we can that is paired up that we could essentially if they were fractions, what would go into them, and we would just throw out the factor, just like we do with fractions. So I know that 3 goes into 9 and 6, so it would become 3y minus 2, and then the same thing here. So we have our answer in factored form, and remember, since these two here are the same, we could also write it this way. Either way is absolutely correct. Alright, so let's try another one out here. So we need to look for a GCF. So is there a number that goes into 7, 11, and 6? No. And they all don't have variable, or an x as a variable. So step 1, we're going to skip. There is no GCF. So then step 2 is we are going to start our parentheses. And we're going to take this and put it here and put it here. Then the next step, step 3, is we're going to multiply a and c. So this is a, this is b, and this is c. So we're going to take a times c, so a is 7, and c is negative 6. And we're going to multiply them, and we get negative 42. So now we need to list the factors of 42. And now that we have our factors, we need to think of which ones will add or combine to make negative 11. So since they have to combine to make a negative 11, I know the bigger number should be negative. And since they need to multiply to make a negative, I know that they have to be different. So if I think about all the combinations here, if I made this a negative 14 and this is a positive 3, that would work. So we're going to put a positive 3 in the parenthesis and a negative 14. And again, these could be switched. Then the next thing we do after we put them in the parentheses is we see if any of the numbers that are paired together can be simplified and if there's a factor that goes into them, and we'll just throw them out. So nothing goes into 7 and 3, so we're going to keep it as 7x plus 3. But 7 can go into both of these. So we're going to write it as x minus 2. And we're just going to throw the 7 out, and we are not going to put it in the front because it didn't go into the original polynomial from the start. The 7 didn't go into the whole thing. So this would be our final answer. Okay, let's try this one. So first thing, see if there's a GCF, a number that goes into the whole entire original problem. So if we take a look at 12, 60, and 75, and I know that 3 can go into all three. So I'm going to put a 3 in the front, and they all don't have variables, so they have no variable in common, therefore. So I know that 3 times 4x squared would get us 12x squared, and 3 times negative 20x would get us this, and 3 times positive 25 would get us the 75. Now that 3 is part of our final answer, so I don't want to forget about it. So it's going to be in part of this final answer that we'll have. So now step 2 is we're going to start our parentheses. So I'm just going to ignore this 3 right now. So I'm going to take this 4x and put it in the front of the parenthesis. And then I'm going to multiply a times c. So a is 4 and c is 25. So we get 100. And now we're going to list our factors of 100. And we need to pick which factors would multiply to 100 but add to our b value, which our b value here is negative 20. So since they have to multiply to a negative, I know one of them has to be a negative, but since it has to multiply to 100, they both have to be the same signs. So if I made both of them negative 10, negative 10 times negative 10 is 100, and negative 10 plus negative 10 is negative 20. So that is going to work. So I'm going to insert my negative 10s here. And then the next step is see if anything can be thrown out. A factor, just like if it was a fraction, if we were reducing 4/10, let's say, what can go into both of them? And in this case, it is 2. So we would have 2x minus 5. And then the same thing here. 2's can go into both of those. So my final answer would be this. Whoops. And that is the same thing as saying this. Alright, let's try another one here. So first thing, see if there's a GCF. Is there a number that goes into 6, 9, and 6? And hopefully you're thinking 3. So we're going to pull a 3 out. And then they also all have x's in their terms. So I'm going to also pull out an x. And now 3x times 2x squared. And 3x times negative 3x. And 3x times negative 2 would be our factored form of this when we pull out the GCF. Now this 3x is not going anywhere, so I'm going to leave it and so that I remember that it will need to be part of my final answer and that it doesn't go anywhere. And now the next step is we are going to start our parentheses like this. Whatever this is goes in the front. And then next we're going to multiply a and c. So this is a, this is b, and this is c. So 2 times negative 2 is negative 4. So now we're going to write our factors of 4. And we need to pick which combination will add to our b value, which is here is negative 3. So since they need to multiply to a -4 and add to a -3, I know that the bigger number has to be negative and that they need to be different. One has to be positive, one has to be negative in order to multiply to make a -4. So these are the numbers we're looking for. So +1 and -4. Then we're going to ask ourselves, is there anything that goes into 2 and 1? No, so it's going to stay 2x plus 1. And then we're going to ask ourselves, is there anything that goes into 2 and 4? So hopefully you're thinking 2. So 2 divided by 2 is 1x, and 4 divided by 2 is 2. So this, and again it's the same thing as if you had this, is my factored form.